Another tricky type of problem that was on the quiz is these ones where they give you a polynomial and they say it has at least one rational zero. They want you to use that fact to find all the zeros of the function. So again, we'll copy down our base polynomial, which in this case is h of x equals 6x cubed plus 37x squared minus 34x plus 7, okay? So we're told that the function has at least one rational zero, and to figure out what the possibilities for that rational zero are, we're going to use the rational zeros theorem. We've talked about this a little bit before, but just a quick review. The rational zeros theorem tells us that if a polynomial has rational zeros, they come from some quotient of factors of the constant term and the leading coefficient. So in this case, factors of 7 and 6, okay? So we'll call any rational zero, and usually use this little lowercase q to express a random rational number. And so it's going to be some quotient of either plus or minus 1 or plus or minus 7. So those are the factors of the constant term. Okay. And then in the bottom, we're going to have plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Okay, and these come to us from the leading coefficient. Okay, so it can be helpful to list them all, okay? So they could be plus or minus 1, okay, plus or minus 7, plus or minus a half, plus or minus a third, plus or minus a sixth, plus or minus 7 halves, plus or minus 7 thirds, or plus or minus even 7 sixths. Okay, so a lot of possibilities. Hopefully, it will be one of these integers, though. Okay, it's always good to start with the integers when you're testing these. So you test these possible rational zeros using usually synthetic substitution. You can also just go to a graphing calculator and see if you can see a zero that way. But if you're pretending that you don't have a graphing calculator, this is the way that you do it. So you have 6, 37, negative 34, and positive 7. These are, okay, these are our coefficients. Then we want to figure out what do we want to try in here for synthetic substitution. General rule of thumb is as quickly as you can bring it close to 0, the better. So why don't we try negative 7? That'll get us at least somewhere in the ballpark. So we bring 6 down. 6 times negative 7 gives us negative 42. Okay. 37 minus 42 is negative 5. Okay. Negative 5 times negative 7 gives us positive 35. 35 minus 34 gives us positive 1. 1 times negative 7 gives us negative 7, and our remainder is 0. Okay. So again, this doesn't work all the time, but it's a pretty good bet. What you want to do is when you're testing possible rational zeros, a good place to start is with a number that when multiplied by the leading coefficient and then added to the second coefficient gets you kind of as close to 0 as you can get. Okay, so in this case, negative 5. Because the goal, of course, is to get to 0 over here. So the sooner you get in the neighborhood of 0, the greater your chances of kind of staying there, if that makes sense. So it turns out that -7 is indeed a rational zero, okay? So we can rewrite our polynomial as h of x equals x plus 7. Remember, -7, so when it's expressed as a linear factor, it's x plus 7, and then we have 6x squared, okay, minus 5x plus 1. This is probably not going to factor easily, so why don't we just head for the quadratic formula. We're going to do opposite of b, so that's 5 plus or minus square root of b squared, so 25 minus 4ac, so 25 minus 4 times 6 times, so maybe we will, so 4 times 6, and then